Okay, so what we're going to talk about now is P2.5, and that is heating and insulating a home. And there's a few key things that you need to be aware of when you're talking about insulating and heating a home. Firstly, heat rises. And the reason why heat rises is because what you've got something called a convection current inside your house, where the warmer something is, the more the particles are vibrating, so they get more spread out, which means they're less dense, which means they float to the top. Okay, so that means that heat rises. So you want to insulate your roof. And the way this is normally done is with some sort of fiberglass. And the key word there is fiber. And what that does is that is trapped air. And if you remember from when we were talking about trapped air previously, because the air particles aren't touching each other, they're very bad conductors. And because they're trapped, they can't set up this convection current either. Okay, so they're stuck. Okay, so once you've insulated the roof with fiberglass, the next step is to put in double glazed windows. And when it comes to insulation, what you want to be looking for is what's the most amount of energy saving for the least amount of money. Okay, because all of these things work, but some of them will have a greater effect for the same amount of money. And what you've got here is, in double glazing, you've got a gas, normally argon or something similar, inside. There's something inert, one of the noble gases, inside your double glazing. And what happens is that if the particles in the glass, they vibrate, they can't pass on that energy by conduction to the gas in here, because they're just not touching it, so they just can't vibrate the energy on. And then outside, this can't set up a convection current in which it can escape, because it's all trapped, so it can only go around in a circle with inside there. So the only way that you lose energy through double glazing really is through infrared radiation. So you've stopped all the other types except for infrared radiation. And that's because, if you remember, this doesn't need particles, this is just light. So this is a type of light that's escaping. And obviously windows want to let light in and out. So you can't stop light, otherwise it's not a window. But you can stop all the other types of radiation. Okay, the next one I want to talk to you about after that is one called, if you have a radiator here, and this is a bit of an exam buzzword. If you ever see the word shiny in an exam, you want to be thinking about emitters and absorbers of radiation. So if it says that you put some shiny foil behind the radiator, or some silver foil, so the word you're looking for are something along the lines of silver or shiny, what's happening is that the radiation is coming in, and then it's being reflected back into the room. Okay, you want to be thinking about it being reflected back into the room. Now, even if you have a loft which is insulated with fiberglass, which has got trapped air, which stops the heat that has risen to the top from escaping, and you've got double glazed windows, and you've got silver foil behind your radiators to reflect the heat back into the room. It's still expensive to heat a house. So the other thing that you can do is you can have solar panels on your roof. Now, there are two types of solar panels. One type of solar panel is a solar heater. And what that will be is that will be a dark surface with some pipes on the inside. Pipes that we made out of copper because they've got free electrons, which means that they're a good conductor. And this surface here will be matte black to make sure that this is a good absorber and emitter of radiation. Make sure you use both. So that'll be an absorber. Good absorber and emitter. So what will happen is that the light will come in. It will hit the matte black surface. It'll heat it up because it will be absorbed by the matte black surface. The matte black surface will then re-emit that heat in all directions, which means that it will go to the copper pipes. The copper pipe will then take the hot water to the rest of the house. And the other thing you need to think about is once it's outside, so in here you don't want it to be insulated at all because you want it to be touching this matte black surface and then transfer the heat into the pipe. But once you're inside the house, you want this to be insulated so that it doesn't lose the energy once it's inside the house. So that's to the house. Okay, so light comes in, hits this, heats up because it's absorbed, and then the matte black surface re-emits the heat into the pipe, and then the pipe takes it to the rest of the house. And once inside the house, the pipe should be insulated so that you don't lose any energy. You use copper because it's got free electrons, which means it's a good conductor. And the reason why examiners like questions like this is because you can see how it ties together infrared, it ties together conduction, it ties together matte black surfaces, it ties together insulating and conduction. So it's a really good question. Okay, last one I want to talk to you about is one called cavity wall insulation. What cavity wall insulation is this? In your house, you've got a brick wall, and then you've got another brick wall next to it. When you have, so if you cut through a wall, you'd see that there's two bricks with a gap. Now that air gap is a reasonable insulator because you can't get any conduction going through here. So that's a cavity wall. Okay, so that's the cavity, that's the wall, and it's the cavity in between the two walls. But it is even better if you drill into the wall and then inject into the wall a load of foam. And the reason why it's better is because that then foam traps the air, so no convection currents. Okay. If you look, before you had this, you had the heat rising, falling, and it take the heat with it when the air's moving around, trap the air. It can't pass on to its neighbour through vibration because it's not touching. So it's very, very good insulation. That's called cavity wall insulation. And then the major types of, so that's all of the major types of insulation done.